This video is sponsored by PCBWay. Welcome everyone. In this video I'm going to show you a little upgrade for my focus stacking rig. So in the previous videos of this project I showed you how I built this PCB here and how you can use it. And then I also showed you my own design of focus stacking rig, which consists of a crosshead here, which moves the camera back and forth, a lead screw, a stepper motor, and some 3D printed parts which make the whole thing into a structure. And now I'm going to show you some other thing which consists of these parts here on the left side and these profiles here next to the rig. And what this thing is basically an attachment for this already existing rig. So you can use this instead of this horizontal alignment in a vertical alignment, something like this. So the camera can move up and down instead of moving forward and backwards. So for that I designed a few 3D printed parts. I have prepared them. So we have 3 parts here and I will show you which part goes where. And then obviously we have the corresponding screws and nuts. And then I have prepared profiles. These profiles, 2 different types, but you can use actually just this type, 2020 aluminum profile, and it's 25 centimeters long, and this is the so-called 2040, 40 because of this length is 40 millimeters profile. I will use this for the vertical part of this rig, and they will be the legs for the horizontal support. So then I will show you how this thing is assembled and how we can use each of these parts. And as you can see, this project involves a lot of 3D printed parts. These guys are for the vertical rig. And then we have a bunch of 3D printed parts here. The supports on both ends of this mechanism, the crosshead, the support for the stepper motor, and the support which holds the camera holder, this guy right here. And then we have this nice PCB which I designed and made it available on my project website on PCBWay.com. So if you want to buy this PCB or you want to get these 3D printable parts, head over to PCBWay.com to my project site, and then you will see 2 projects there. One is dedicated for the PCB itself and another dedicated for the mechanical parts of this rig. If you want to order the PCB from PCBWay, then go to that site and then just put it in your cart and order it. Or you can go to the page which is related to the mechanism and then you can get the 3D printable parts from there. So let's head back to this project and let me show you how I build the vertical rig, and then you can follow the same kind of practice or same kind of path to build everything. So the idea will be that we will have this rig in a vertical alignment. I show it in this way, so you can see the back of this. And then I will use this 2040 on the back side here, so this will be lifted. I will show it from a different perspective once it's built, but you can see that it will be something like this. And then we will have the 2 legs, one of these modules or profiles on each side. And then I will use these 3D printed parts to keep everything in place. So first let me put together these pieces so we will have a stable leg. So I printed this piece and the center is properly sized, so I can insert this with a very little motion. So it barely wiggles, it fits very nicely. And then I will use a few screws just to fix it temporarily. So this is like a proper T-nut, as you can see, hopefully, once we get the focus there. And then we have this very simple nut right here. I will tell you the lengths, the threaded parts lengths in a moment. So it's exactly 1 centimeter, 10 millimeters. So that's the threaded length. And the size is 5 millimeters, the diameter. So this is an M5 nut. You can see there. And just to return to this plastic part, all the holes are designed in a way that they are a little bit below 5 millimeters. So what I suggest is that you take a 5 millimeter drill bit and you ream all the holes, either by hand or just put the drill bit in a drill and just ream it. So then there will be a snug fit between the bolt and the hole here, which contributes to the mechanical stability a bit. So now all the bolts with the nuts are installed, as you can see. So the only thing that we need to do is that we align these nuts in a vertical way so they can slide into this rail. And then I will try to put everything together. So now it's on. So then we can attach the feet. And that goes along the same strategy. So we align these nuts and then just slide on the profile. And now I will put this in the center, roughly, like this, but it might need some adjustment later on. As you can see now, I have the legs attached, but I want to make sure that they are properly aligned. So here is a very flat steel plate. And then I just put this there, and now I will just fix the screws. So then what I want to ensure is that here everything is in level. So then when the camera is installed, it will be really vertical, or it will be as vertical as possible. So now I just fix this on the flat surface and then fix everything together. Basically, I will just start with the side screws. So now the flatness is ensured. And now the only thing I have to do is I have to make sure that they are along the same line. So then it's more or less fine. So they are more or less symmetric. So then I just have to make sure that I tighten these screws because they are somewhat loose now. So I just fix them. So now comes the part when I attach the leg together with this part. And for this I made 2 different parts. They are almost identical. I actually had a very little work to convert one of these parts into the other. I started with this. I drew this in Fusion 360 as usual, and you can see that it has an end cap. And this will be on the top. So it will have some support against, let's say, the vertical motion. There should not be any motion like that, but it will sit here as a cap, you can see. And then it will sit on the back. And then the other, this guy, will sit down here just to have an additional support against any kind of bending. Because if I just fix this back side, let's call it spine, against the back of this thing, with only this piece, then that would lead to some nasty injuries to the camera system, because you will attach several kilograms of camera on this, and you don't want it to be supported by just one piece of small plastic thingy, so it will look something like this. But before I can mount this thing on the back side, I have to do the dirty job and put in these guys into the corresponding holes. So let me do that. So it is done. All the screws and nuts are fixed. So we can start with the top. So then again, we just align them here and there and just put the cap on. Now it doesn't matter which side because the legs are symmetric. So then I just hold it like this so I can see the screws here and just fix the screws. Not easy to show it on the video, but they are perfectly perpendicular to this groove here, so that's fine. And then I can start mounting it on this guy. So this is also the same length as this guy, 25 centimeters. So let's say I want to have it roughly in the center. I can measure it, but now I just eyeball it because I know that I will have some extension mounted on my camera. So I will need some space down here just to move up and down. And mounting this thing at the center, or roughly at the center, seems to be a good idea. So again, they have to be vertical, so they are aligned with these grooves here, and then just put everything together here. So this is mounted, and as I said, I want to have a support at the bottom, because if there is any kind of twisting, like these things are twisted, this against this, then I don't want to have this guy to be the only support. So because of that, I just have this part, which is identical to this part, but it doesn't have a cap at the back, like here. So then again, we align the nuts. And just put it on. And then I just fix the screws. So it's done. We have a very robust structure here. I will change the camera angle and we will look at this from the side view. So it will be more easy to look at this thing and understand how it works. And obviously I will also test it. So let me change the camera. So before mounting the camera, let me weigh the system. So you will see what is the load on this thing. So 959 grams. And this is an Nikkor lens, flipped on this bellow. And then I have a Sony Alpha 6000. So once again, 959. And some viewers asked if this rig can withstand 2 or 3 kilograms. So I will test it somehow. I will add some extra weights on the structure. I will show it how I do it, and then we will see if the camera can still be moved in a repeatable manner and so on. So now let me mount everything and then we see how this thing works. So now you can see the system assembled. So the camera is sitting here, and then here is the mechanism, and then here is the spine and the legs. And the reason why I mentioned that you should pay attention to the balance with these legs is because of this arrangement. You can see that the center of weight is somewhere here, so it's way forward as compared to the spine, where you should have the center of weight. So if I would push this a little bit more than I would need to, then this could tip over, but you can see that even at like extreme angles it falls backwards. But still I want to emphasize and let you know that you should pay attention to the position of these legs. So you might want to move this leg forward by, let's say, 5 centimeters and put some weight here on this side. With that you can like move the center of weight backwards and stabilize the rig. So even if you touch it accidentally, it will not tip over. But you can see that it's stable and it will not fall very easily. But I just want to save myself and your rig as well by saying to pay attention to these details. So now what I will do, I will attach the PCB and then we will do some experiments. And what is the most interesting experiment for me is that how precisely I can move up and down. So then I will use this dial gauge, or I don't know what its exact name, but I will use this and I will attach this tip to somewhere where I can measure the up and down displacement properly, and then I will see how repeatable the motions are and so on. So we can be sure that, for example, this thing can really move this kind of load. And if you remember, now we have 956 grams here, so we will see how precisely we can move that for now. But for that I have to rearrange everything and record this thing, so you will see what is happening. So first let's look at the display. So now I have the laboratory power supply, it's attached by these clips here, the motor is also attached, and now we don't care about this infrared LED, but it's here. So I just turn on the power supply and it's on, and we do not want to perform homing. So you can see that one click is like this much movement. I will put some more details on the display. So then let's see what the dial shows to us. So let me relocate the camera. So this is the dial, but it's not on, so let me turn it on. And let me zero it, roughly. It's very sensitive to these motions. So it is what it is. I will flip this display so you can see what happens, but just listen to the noise and see the display. So this was one step, another. So now you can see that we are at 0.09. So one more step should be 0.10. So it works quite nicely. And what happens if I move like continuously? So you can see that it moves in a very fine manner. Now I switch back to rotary encoder. And once the backlash disappears, then it moves with the proper steps, as you can see. So now I have to find some extra weight and test it again. So I will show you the scale again, so you can see that I'm not cheating, and then I will also show you how I attach the weight somewhere here. So let me prepare those things. So the scale is here, and if you remember, we have the camera's weight around 960 grams. So I can use this steel plate, which is 1 kilogram and 325 grams. So together with this, I have 2 kilograms and yeah, roughly 300, almost 2.3 kilograms total load. So I will put this on the top of the camera, so on the very top of this thing, and then we will see how the structure behaves. I will show you how it is mounted on the camera. So here is the camera, and my plan is to just put the steel plate on top of it, like this. So then I can also put things on top of this as an even extra more weight. But now, at least on this axis, we have 960 plus 1325 grams. So now I check for the displacement again. So here you can see the dial. I try to reset it. And there is always some residue. And then I will try to move this thing. So as you can see, one step is still 0.01. Oops, I moved this. Whatever. So one step is still 0.01 millimeters or 10 micrometers. So that's fine. So now let's see how this moves up and down. So let me check. Where should I move with this? So now this moves downwards, if I'm not wrong. Yes, I'm wrong. This moves upwards, and you can see that it moves quite evenly. And actually that would be a better test for this, because it's a bit more hard to lift the weight in a sense that the wall structure or the wall mechanism also works against the gravity if it moves upwards. And then if you scroll back in the video and check the displacement of this part, you will see that we are moving upwards. I'm just not very familiar with the directions here because the rig is upside down and so on. So yeah, this is now my first trial. Yeah, it moves nicely. Now I move downwards. So now I press the button and you can see that nothing is happening because there is a backlash, but that is expected. When you change directions, there is always a little backlash, despite the fact that I'm using the anti-backlash screw. And now the thread started to engage with the lead screw. So one click should be 0.01 millimeters again. Maybe it's better if I use the rotary encoder. So it moves well, but the load here is only, let's call it 2.3 kilograms, and a viewer asked 2 to 3 kilograms. So I need to find the 700 grams somewhere and put it on the top of that steel plate and see if I can still move with this thing. So let us do it. So scale is on. I have this nice cup. You can see that it is heavy as well, 418 grams. Then I have this measuring tape. It fits in the cup. So 673 grams. And just to be sure that we are over 3 kilograms, 836. So 959 plus 1325 plus 835. I cannot do the math so quickly, so I write it on the display, but it's over 3 kilograms if I'm not wrong. So I put this on the top of the steel plate. So this is how it looks. It's a bit scary, but it's there. So again, here is the dial. So when we move down, the number becomes more positive. If we move up, the number becomes more negative. So I just reset it. And of course I bumped into it, so it's not exactly 0. Some percussive help might make it 0. No. Yeah, whatever. So we are starting at minus 0.01 millimeters. And now I just move a little bit just to see the directions again, because I forgot them. So if I'm not wrong, more negative is downwards. No. So this was upwards. And this is the more important. So as you can hear, there is one click and there is 0.01 millimeter of change. And sometimes it jumps 0.02, but I believe that that is because of the resolution of this thing. So it cannot resolve the last digit properly. So of course, sometimes there will be more than 1 or less than 1. So then that's how it is. I need a better dial. It moves well, so I press the button now. And it travels just fine. As you can see, the numbers change very smoothly and in a very nice pace. So the motor can move this thing. The mechanism can withstand the load, as you can see, more than 3 kilograms. And yeah, everything seems to work. So this works just fine. Now I change directions. So again, there will be some time when the numbers don't change due to backlash. And now it started to engage with the threads again. So now I'm moving downwards. If you keep your eye at this point, at the end of this needle, and you see the text in the background, you can use that as a reference point. And you can see that we are moving downwards. And once again, we are moving downwards in a very smooth way. There are no hiccups in the motor. Everything moves evenly. You can see the step size and the rate. Everything is very smooth. So it works just fine. Now I'm stepping again with the rotary encoder, 1 click at a time. So I think I demonstrated everything that I wanted. So I showed you how you can put together this mechanism. I show you in a moment. So I'm talking about this part. So this is the top part with the cap. This is the supporter for the, let's call it, spine. And down here we have the rest of the support, which connects these two legs with the spine. So then this holds the wall structure. You can see it here. Maybe from a bit different perspective as well. So here towards this, towards the top of the picture, we have the lens, the bellow, and then the camera and all the weird weights on it. And then everything moves just up and down. And you can see that it moves very smoothly. So I just show you from another perspective. So it moves very nicely. So eventually my little stuff can work with heavy cameras as well. And that's really nice. So you can see that if you build this thing together with the PCB, you will get a, let's call it a reliable system for focus stacking. So I hope you can replicate this thing at your home and then enjoy it. I will have a lot of good adventures with this. I will take a lot of pictures with this. I just need to find some time. But yeah, everything works. So once again, if you want to have the PCB or you want to have these 3D printed parts or whichever 3D printed parts I showed, please head over to my project site on PCBWay's website, and then you can get everything from their services. And then also, if you want to support my work and want me to make more videos in this kind of topic or any kind of topic that you wish for, please consider supporting me on Patreon. Also, if I publish something like a big source code or stuff like that, that will be available for my Patreon supporters for download. So that's also quite beneficial. Also visit my website because I wrote an article about this thing, and you might find some useful insights there, which I probably forgot to mention here in the video. And also on my website, there is a section or a sub-page called Tools, and that is the part where I share all the mechanical parts and all these things like this steel shaft or this mounting plate for the camera or the lead screw or these aluminum profiles. I took pictures of them, and then I have my affiliate links with them, so you can buy them very easily and you can support me at the same time without paying anything for me, basically. So head over to my tools webpage and you will see what is offered there. So I hope you found this video useful. I hope that this demonstration, especially with these heavy loads, was useful to you, and I hope I could help those guys who asked about the, let's call it, capacity of this equipment. So I hope that was useful to you. I hope you learned something, and see you in the next video.